Hi everyone. So what we're going to look at today, well, if you can make that out, that's meant to say triangles. Right, that's the exciting part over. Okay, go to the last page. Just as a little reminder, when you were dealing with triangles in the past, you dealt with something called Pythagoras' theorem and sine, cos, and tan, or SOHCAHTOA, maybe. And for Pythagoras' theorem and the sine, cos, and tan situations, they all had something in common. You needed to have a right angle there. That's one of the angles within the triangle had to be 90 degrees. So we're moving up a level here, and we don't necessarily have one of our internal angles be 90 degrees. So it's now quite important, as is the title here in this page, about the labeling of triangles. I'm going to be using letters here. It doesn't matter what letters I use, as long as I'm consistent. So I'm going to be using large letters or uppercase letters for the angles or corners or vertices, whatever you want to call them. I'm going to be using the lowercase or small letters for the sides, kind of opposite them. So let's go. That's just what I've said there. So I've just pick a corner, any corner, right? Vertex. So that's A. And I just want to emphasize, so that can be this angle inside here. That's what I'm referring to. So the important thing is, if I come across from this angle A without touching these two sides that create A, I hit this third side, I'm going to use the lowercase a. Go to another corner, vertex, whatever. So that's angle B. So if I come across from it, and I'll label that side small b. And guess what? That angle is C. Come across from that, that's small c. Right, so if we use this convention, whether it's A, B, C, P, Q, R, X, Y, Z, it doesn't matter. As long as you can associate the big letter for angle with the opposite length, then you'll be fine. Okay, we're just going to go through this wee bit at a time. So area of a triangle, various ways we can look at this. And so I'm just throwing this one in here. This is maybe for something that you learned at school. Use a little formula there, half times b times h. Just remember, folks, when things are stuck together, they're multiplying. So it's half times b times h, whatever b and h are. So b is what I would refer to as the base length, and h, and hopefully you notice there, I've got a little square in there. That means that's at right angles to b. So h is a perpendicular height. So this only works if we know what the base length is and the perpendicular height from that base length up to that pointy bit at the top. a lot of time in triangles we only have like the measurements of the lens, and we don't necessarily have this internal measurement. So if we don't have that, then we need to use other methods to get the area. So here, what we need to have is we need to have two sides. As long as we got two sides and the angle that's between them, or I used the wording created by them, then we can still get the area. So it's any two sides. It doesn't matter what the lettering is. Again, I'm using capital or uppercase letters for the angles, lowercase letters for the sides. So I've just ticked off like sides X and Y and the angle between them, capital Z, Z, zebra, whatever you want to call it. As soon as I've got them, now I can calculate this area. It's basically just half times the two, or half times the product of the two sides times the sine of the angle between them. Right, okay. This time I've moved it about. So the two letters here for the sides are X and Z, X and Z, Z and X, whatever you want to call them, and the big letter Y for the angle between them. So this time it's going to be half times the product of the two sides, X and Z, or Z and X, times the sine of Y, the angle between them. Okay, thirdly, I've got Z and Y, or Y and Z for my two lengths. So it's going to be half times Z times Y, or Y times Z, or Z, what you call, times the sine of the big X, because that's the angle. Right, so for that triangle there, I went through all kind of three possibilities of what could occur in order for us to obtain the area. As long as you've got the two sides and the angle between the two sides, you can calculate that area via this formula. So in general, it's going to be half AB. It doesn't have to be those letters. AB are the two sides times the sine of the angle between those two sides. I'm calling it C here. Or just remember, because this is a recording, a wee video here, you can always pause it and tune it in Netflix. No, you can always pause it, have a wee think, or rewind, see what's going on. Okay, let's go for a wee example here. Let's calculate the area of this triangle below. Looks like we've got two sides of 8 centimetres, 7 centimetres, and an angle between them of 30 degrees. So it looks like everything's in the right position. So what I'm saying here is label the sides. Well, if you want to, sometimes you don't need to, sometimes it's good to. And you can pick whatever letters you want, as long as it fits in with the formula. So we get two sides and the angle between them. So I'm just going back to that. That's my standard. And so I think I can put in my numbers here. I don't have to use multiply signs between the half, the A, the B, and the sign C. If I use brackets here, it'll come out the same. If you're in my class, you will have seen I did it various ways. Okay, so let's type this in. 1 divided by 2 times 8 times 7 times sine 30. Fire it in the calculator. Should be a nice answer because this is my first example. Evaluate, work out, get a value for your answer. 14, but the thing is, I've got units of measure here. I've got centimetres squared because I've got 8 times 7, I mean centimetres times centimetres is centimetres squared. Sine 30 is just a number on its own, a naked number. But units of measure are important here because we're dealing with error. Okay, square feet, square yards, square centimetres. Right, this one is for you, folks. So you pause the video here and have a go at this. 5m, 4m are the sides, so you might interpret them as meters for the 5m, and so 5 meters, 4 meters. That's fine. And the angle between is 45 degrees. So just you have a wee think to yourself. I'm not putting any letters here. Have you done? Can I go ahead? Aye. So I'm going to pick the formula. So I'm just going for the general formula. Half times the two sides times the sine of the angle between. So I've just put in wee brackets. I'm just going to put them in. 5 times 4, 4 times 5, that doesn't matter. You get the same result. Times the sine of 45. If you put that in your calculator, what's a half times 20? It's 10 times sine 45 is, oh, it's 10 over root 2. That would come out to 5 over root 2, 7 and a bit. Yeah, okay. If your calculator's giving you something like 5 root 2, that's the same as that, except this is a decimal answer. So just ask your pal if you've got one, or ask the lecturer if they know how to work your calculator. But really, it should be your job to know how to work your calculator. Forget about that. Okay, that's us done with the error. We're now going to look at two versions of what's called the cosine rule. The first one is to evaluate the length of a side that we don't know. So here's the formula. A squared equals B squared plus C squared. I just want to let you notice something here. See that first part? Does that remind you of anything? A squared equals B squared plus C squared, or X squared equals Y squared plus Z squared or Z squared. Well, that reminds me of Pythagoras' theorem, but that's only when you've got a right angle. And because we don't have a right angle, we need to compensate. We may need to make a wee fudge, and the wee fudge is this bit at the end. So it just lets you pretend we've got a right angle triangle. Right. Memorize that, please. So this is the same as the area in terms of information. We've got two sides and the angle between. Two sides, angle between. And you notice that B and C are there, and B and C are there. The two sides we know, two sides we know, and the side we're looking for is opposite the angle we have, actually. So let's go for this one here. So if you take that there, okay, doesn't matter to change the letters, just put everything in the right position. So you take that there, okay, have you written it down? Why not? Well, you should have. Let's go and try and evaluate that. So what we do have is we'll get two sides and we'll get the angle between, and we're looking for this third unknown side. So hopefully you've halted the video, used the format on the previous page and try to attack this. Anyway, I know a lot of you don't do that kind of thing, so I'm going to go for it. I'm just going to use that format. Doesn't matter what the letters are. Doesn't matter. It doesn't matter if I got an X here. That's going to replace A, right? So that don't get all hot and bothered about that. Okay. Here, I like to use little brackets, so I've just got rid of all the wee letters, the big letter. I'm going to put in my numbers here, my values. So I'll put them in and see with your big grown-up adult calculators, you should be able to type that in. If you want to use the brackets, that's fine. If not, then you might have to, between these three, 2 times 10 times 9 times cos 60. And so let's see what kind of number we're getting out here. 91. Okay. 91. So it's finished. I don't think we have, because we are looking for x, and that's x squared. So something times something. So we need to undo the something times something to get back to x. So the x squared, the opposite of x squared, hopefully you know, is the square root. So square root, oh, 91, that's no nice. If that was 81, that would be nice, because that would square root of 81 would be 9. And the next square up is 100. So that lies somewhere between 81 and 100. So if you go and square root 91, it'll give you something like 9.5, or 9.5 and a wee bit actually. I haven't stated anything about decimal places, so you just do what you think here. I put 9.54, you can put 9.5, and some people might have had 9.53 something or other. I'm not exactly sure. Aye, so but 9.5393, it doesn't matter. If it's not an exact whole number, if it's 9 and a bit, go for some wee bits here. Right. Don't get all worked up about it. That's the kind of workings I would expect, or especially for an assessment, because you get marks for putting in all the workings. Okay. Right, let's move on. Right. Depending upon what kind of group I've got, you don't necessarily need to know how this happens. If you've done transposition of forma or not, if you've done transposition of forma, actually, I'd be surprised if a lot of you can actually transform this to get big A on its own. I'm going to show you. I'm not going to explain it, I'm just going to show you, and you can go back and look at it in the privacy of your own bedroom, bus stop, or wherever, favourite eating haunt, and go to there. So sometimes I leave it like that. Cos A equals B squared plus C squared minus A squared on the top, divided by 2BC. Or I like to take it all the way to get A in its own. So I need to get rid of that cos on the left hand side. And the opposite of cos, it's inverse cos, or cos with a minus 1. So I take it all the way to there. So basically, I've taken the first rule, which lets you know an unknown side, to this one, which lets you calculate an unknown angle. I'm just showing you the two versions. This is my preference, but sometimes I don't know why. Some people or institutions leave it like that there, and maybe they think it's simple just plugging in the numbers here and taking the inverse cosine that we've got up here. Nobody has explained that to me. Right, regardless of what one you use, you're going to get the same result as long as you take the inverse cosine to take it to that step there. Okay, let's go for this. So we've got all three sides, and the thing is, A, B, C, and B and C, this involves all three sides, and that will give us any angle, regardless of which three sides you went for. But the thing is, it's very, very important here. Very important about the labelling. The angle I'm referring to as x, an internal angle. I'll probably refer to that as big A in terms of the general formula, but I'm going to come across from that. I'm going to call that small a. Okay. So and then I know what I've called x initially, it doesn't matter. I'm just going to call it big A so that it'll fit in with the big formula, the general formula. See the 8 and the 10, the two other lines, they can be B and C, it doesn't matter. It doesn't matter, everything will work out all the same. And you can try it later on. Okay. So there we go. I'm just going for the inverse cosine, all the stuff in the bracket, b squared plus c squared minus a squared over 2bc. And please notice, see the b and c there? They appear down there as well. So that's a way to remember it. And the side opposite the angle you're looking for, that's the one you're taking away the square of. Let's remove the letters. Let's put in the numbers. And I like to just work out the top line and the bottom lines because I don't trust my calculator. So 10 squared plus 8 squared. So that's 164. Take away 25, whatever that is. Then 2 times 10 times 8, whatever that is. So you're going to get two numbers here. So you put them in your calculator. I think it is 139 over 160. So now put in shift cosine or second function cosine. So you should see cos with a minus 1 in your calculator, and it should open a bracket, then do 139 divided by 160. or use your fraction key, whatever. But close your bracket after that, right, and see what you get. I know I'm not going to get an exact whole number. I know I'm going to get a decimal, so I'm going to go for 1 or 2 decimal places here. Some of you might have went for 29.7. I went to 29.69 there. That's fine. Some of you might want to go to 3 decimal places, be something like 29.686. And some of you might want to write down the whole answer in your calculator to be on the safe side. That's okay. If they don't specify a number of decimal places, go for at least one here. The only thing I've done here is I've changed the location of x. I'm using the same triangle. Look. So you go for that there. It means when we come to relabel things, that'll be angle A. That'll be small a, and these are B and C. Okay, so I'm giving you a clue. Take your general formula. A squared equals B squared plus C squared minus 2bc cos A. And you go for it. So look at my new labeling system here. Big A is the angle I'm looking for, so that's automatically small a. B and C, it doesn't matter what they are. Okay, it'll still work out the same. So there's your general formula there. Again, halt the video if you want to take your time. I don't want to get ahead of the game. Okay, I'm going to put numbers in here. So A is the 8, so the 8 is going to square this there. B and C are there. So sort out the top, sort out the bottom. So 10 squared plus 5 squared, that's 125, take away 64. Whatever that gives you. Over 2 times 10 times 5, 2 times 10 times 5 is 100. So what you're going to get, something like 139 over, what's that, 100? Oh no, sorry Tommy. 61 over 100. That's okay. So at this point here, this is where we go for the calculator. The shift cosine, second function cosine. So as long as this appears in your calculator, it will give you a bracket. 61 divided by 100. Close the bracket. Equals 52.4. I'm always chopping and changing the number of decimal places I'm going for. Doesn't matter. I could have had 52.41, I could have had 52.410, 52.410497004. You just round it to whatever you want, because nobody's actually asked you about a specific number of decimal places. Right, okay. Okay, so here, basically, here are the two formulas for side and angle. Basically, this one for side and this one is just a rearrangement or vice versa. That's what they are. So what I'm actually going to do here, I'm going to finish this. So what we've dealt with here, the area, that's fine, that's 5 minutes worth of stuff. But the main event was the cosine rule for side or angle. So I'm not going to go overboard. And then the next one, so this was the cosine rule that we spent most time on. So the next thing I'm going to look at is a thing called the sine rule, whatever that is. Yep, 31 and a bit. Let's finish it here. Good night, good morning, good afternoon, wherever you are.